This is TechCrunch.
It's no secret that the electrical grid is aging, but one part stands out from the rest. Transformers haven't changed much since Thomas Edison made his first light bulb. Now, a string of startups are working to modernize the transformer, replacing it with modern power electronics that promise to give grid operators more control over how and where electricity flows. 3 startups recently raised sizable rounds to scale up production of their solid-state transformer technologies. This week, DG Matrix raised a $60 million Series A, and Heron Power raised $140 million in a Series B round. In November, Amperezen raised $80 million to chase after the burgeoning data center market. Existing transformers are reliable and efficient, but that's about it. They're relatively crude instruments, made largely of copper and iron. They react passively to changes on the grid and are capable of tackling only one task per device. Drew Baglino, founder and CEO of Heron Power, told TechCrunch, "An old-school steel, copper, and oil transformer doesn't have any monitoring, doesn't have any control. In instances where electricity surges or a power plant trips offline, that can be a liability. The devices can incorporate power from a range of different sources, including traditional power plants, renewables, and batteries, and transform that electricity into either alternating current or direct current at a number of different voltages, allowing them to replace several devices. For data centers, solid-state transformers offer an appealing alternative, allowing them to shrink the footprint of their power systems while giving them finer control over where and how electricity is directed. Solid-state transformers poised to arrive at a time when existing transformers are aging and demand for new ones is surging. A classic tech supercycle. Most transformers on the grid today are several decades old, according to the National Laboratory of the Rockies. As demand from data centers, EV chargers, and other parts of the grid rises, the NLR expects the amount of power flowing through transformers to double by 2050. While data centers are the first market those companies are chasing, they also have their sights set on the electrical grid, which in the US alone hosts as many as 80 million transformers. Baglino said that all of the distribution transformers are ultimately going to need to be replaced. Over 50% of them are 35 years old. There's a big need for an upgrade. Because they are made from silicon-based materials, they're flexible, controllable, and software updatable. They're also immune from price fluctuations that rock the copper market. Baglino added that power semiconductors keep getting cheaper. Steel, copper, and oil are not in that situation. Commodity prices can move all over the place, and they generally move up. In an old-style transformer, power flows into the transformer through copper wires wound around one side of an O-shaped iron core. As the electricity flows, it induces a magnetic field in the core. On the other side of the core, the magnetic field induces electricity in another set of copper windings. If the wires wrap around the core more times on the input side than the output side, the voltage decreases on the output side. If the ratio inverts, the output voltage increases. Solid-state transformers eschew the copper windings in favor of semiconductors, using materials like silicon carbide or gallium nitride to handle frequency conversion. They can come in a range of configurations, with the most comprehensive setup consisting of 3 basic parts: a rectifier that converts alternating current to direct current, a converter that changes the voltage of the direct current, and an inverter that changes the direct current back into alternating current. Unlike iron core transformers, solid-state transformers can handle power that flows in both directions, making them useful in places that need backup power, like data centers. In a data center, a solid-state transformer can replace several different pieces of equipment, not just the transformer that steps voltage down from the grid. Every data center uses backup power, which requires a string of devices to bring power into the facility. Solid-state transformers can handle all of those duties in one box. The technology also allows data centers to more easily integrate so-called behind-the-meter power, where generating capacity is connected directly to the data center, not the grid. Those typically require another set of transformers. And when coupled with grid-scale batteries, solid-state transformers can eliminate uninterruptible power supplies too, freeing up space inside the data center for more racks. DG Matrix has been focusing on its interport technology, which can route power from multiple sources to multiple loads of differing voltages, a setup the company holds multiple patents on. Heron Power, meanwhile, is working to transform medium voltage power in data centers, solar farms, and grid-scale battery installations. In a data center, its Heron Link transformers can provide racks with 30 seconds of power while backup sources come online. Altogether, Heron Link occupies 70% less space than existing parts. At a solar farm, Heron Power's transformers can perform the duties of an inverter and a transformer for the same price. In a head-to-head comparison, solid-state transformers still command a cost premium over iron core transformers. For that reason, they're unlikely to replace the giant humming boxes at grid substations in the very near future. But in data centers and at EV charging hubs, where solid-state transformers take the place of several pieces of equipment, they'll start making inroads. When they finally hit the grid in bigger numbers, they have the potential to cut down on transmission and distribution costs, one of the biggest contributors to utility bill inflation. Because today's transformers are passive, unable to react to fluctuations, Baglino said that distribution networks have been built with a significant amount of spare capacity. Solid-state transformers, though, and can respond to changing conditions, allowing grid operators to send more power through the same lines. He added, "You can actually make the infrastructure more affordable because you're putting more kilowatt hours through the same poles and wires. That's where intelligence, in place of passive mechanical objects that were designed 100 years ago, can make a big difference." That's it from TechCrunch. For more stories like these, go to TechCrunch.com.